Here we go with another incredibly detailed restoration by the master, Sophie. Today, we're restoring this completely wrecked 2000 Hello Kitty limited edition Sega Dreamcast console. Right from the start, you can see the disc tray lid won't stay closed, and opening the case reveals clear burn marks on the power module. The owner also mentioned screen flickering just days before it died, but we'll need a full tear down to diagnose all the underlying issues. And this broken latch is exactly why the disc cover won't stay shut. As Sega's ultimate passion project, the Dreamcast has tons of amazing features, which we'll explore later. For now, the master has finished the initial teardown and is moving into the repair phase. First up is the scorched power module, and he's removing the larger components to properly diagnose the issue. Wow, a capacitor is completely fried, sitting right between the main capacitor and the high-frequency transformer. This isn't just standard circuitry, it's the high-voltage switching core that converts DC power into high-speed pulses for the transformer. If the capacitor ages, gets damp, or a switch fails, the current instantly surges, causing severe burns like this. After diagnosing the issue, he deep cleans the board using multi-purpose foam, TSP, contact cleaner, and isopropyl alcohol. The highly alkaline TSP breaks down carbonized grime and soot, leaving the board looking pristine after the wash. The removed voltage regulators, high-frequency transformer, and EMI filter also receive the exact same deep cleaning treatment. Following the schematics, he replaces all the burnt components with new ones and reinstalls the parts he just cleaned. Once everything is soldered, he powers it on to verify if all output voltages meet the required specifications. He also thoroughly cleans and tests the power switch cable, confirming it works perfectly again. The cooling fan is also restored to its prime condition, leading us to the I/O control board next. He uses a heat gun and soldering iron to remove the cover and the factory soldered Sanyo 2430 coin battery. To make future replacements easier, he upgrades it with a standard coin battery holder. Beyond regular cleaning, he files down the socket pins, which reminds me of an old trick I learned as a kid. Whenever APC lagged, you'd pull out the RAM and clean the gold contacts with an eraser. An old school but incredibly effective fix. After cleaning, he thoroughly tests all the capacitors and the overall functionality of the control board. Once verified, he installs the new battery socket, reconnects the cables, and attaches the cover, finishing the I/O board. Next up is the disk drive, and as always, a true deep clean requires a complete tear down. This drive is missing its laser lens cover and top panel, but as a core component, it boasts some fascinating engineering. Unlike standard CD drives, this unit uses GD-ROMs, which look identical to C-disks but function very differently. GD-ROMs have a much higher data density for larger games and are split into distinct inner and outer zones. The inner zone holds audio and boot data compatible with CD players, while the outer high-density game data zone is unreadable by standard devices. This proprietary disk format served as an ingenious early defense against software piracy. He meticulously removes and preserves the original warning stickers during the teardown so they can be reapplied later. Now he's servicing the spindle motor responsible for spinning the disc, adding fresh grease to the rotor after a thorough clean. The optical sled motor gets the exact same top-tier treatment before he tackles the heart of the drive, the laser assembly. You can see the ribbon cable is completely severed, but this unit also houses the focusing lens and the laser diode. It includes a photodetector for reflected signals and a focusing coil, all working together to read data by scanning the disc's microscopic bumps. The reflected laser light is converted into electrical signals, which are then decoded to retrieve the game data. The original glue holding the focusing lens has deteriorated, so he uses epoxy to firmly secure it back in place. As mentioned earlier, the laser assembly was missing its cover, which he ingeniously replaces using a 3D printed part. Reassembling the guide rails wraps up the laser unit, moving us onto the optical drive control board. This control board dictates motor movement and processes signals. If the motor is the muscle and the laser is the eye, then this board is undeniably the brain, which he thoroughly tests after cleaning it with cleaning slime. The board checks out fine, but he preemptively replaces an aging capacitor to ensure future reliability. He also addresses the mounting holes linking the board to the heat shield, which serve as crucial ground connections. If this ground connection is unstable, all signals lose their reference point and become completely unpredictable. Next up is the optical drive's metal chassis, where he applies a specialized rust removal gel to chemically treat the corroded areas. After letting it sit for 2 hours, he washes it thoroughly along with the rest of the components. Once perfectly clean, the metal chassis is coated with a protective layer of silver anti-rust paint. With all the optical drive parts fully restored, it's finally time to reassemble the entire unit. As mentioned earlier, this Sega console uses proprietary GD-ROM discs, holding much more data while preventing regular drives from reading them. It seemed like a brilliant anti-piracy measure at the time, but the system also supported a multimedia format known as MIL-CD. MIL-CD was intended to add extra features, allowing the console to run interactive media content and video playback beyond just games. However, hackers soon discovered that by masking ACD's front end as audio tracks and appending game data, the MIL-CD exploit allowed direct booting of burned games. No mod chips or hardware hacks were required, just a standard household CD burner gave you endless access to free games. In theory, this exploit was patchable, but the flaw wasn't inside the games, it was hard-coded into the console's startup logic. For the hardware units already sold, updating the firmware was practically impossible back in those days. Sega eventually disabled this feature in later hardware revisions, but by then, millions of exploitable consoles were already in living rooms. Piracy was completely out of control, and locking the door was useless when the intruders had already taken over the house. This critical oversight was a major reason why this beloved Sega console had a tragically short lifespan of just over 2 years. Back to the restoration, the master uses conductive silver paint and a patch to flawlessly repair the torn original ribbon cable. He replaces the missing top panel with a genuine second-hand part sourced online, securing the plastic shield to finish the optical drive assembly. Moving on to the motherboard, he uses cleaning slime to pull up the vast majority of dust and surface grime. This massive chip right here is the console's GPU, specifically the PowerVer 2 designed by the British company Videologic. Right next to it is the smaller Hitachi SH for CPU, and you can check the on-screen graphic for the full system specifications.
After the initial wipe-down, the motherboard undergoes a meticulous deep clean and a comprehensive diagnostic test.
The board checks out fine, but if that screen flickering issue persists during testing, all components in this highlighted red zone will need replacing. We won't know for sure until the final boot up, so for now, the next logical step is tackling the console's casing. As always, it starts with a vigorous wash to scrub away years of dust, dirt, and stubborn glue residue. To reverse that unsightly yellowing, there's no better solution than utilizing the classic retrobrite method. The yellowed plastic parts are submerged in hydrogen peroxide and exposed to prolonged, direct ultraviolet light. This process generates highly active hydroxyl radicals that break down the conjugated structures, causing the discoloration, magically restoring its crisp white finish. The master initially tried making custom rear labels, but since they weren't perfect, he sourced genuine second-hand replacements instead. Skipping the cleaning montage for the transparent shell, he jumps straight into fixing the broken latch that prevents the disc tray from locking. The plastic clip had snapped off, and merely gluing it wouldn't be strong enough, so he implants a reinforcing steel pin inside it. Actually, one isn't enough. He adds 2 pins for maximum durability before reassembling the beautifully cleaned transparent casing. While that glue dries, let's talk about another brilliant technical marvel of this console, its unique GPU rendering architecture. Standard 3D rendering typically draws everything in a scene first, then mathematically calculates what is hidden and what remains visible. Rendering unseen objects wastes massive amounts of processing power, so the Dreamcast splits the screen into smaller independent tiles instead. It determines exactly what will be visible in those specific tiles and only renders those areas, an ingenious method known as tile-based deferred rendering. By not wasting precious energy drawing hidden geometry, it saves tremendous performance, resulting in incredibly sharp and striking in-game visuals. The textures remain exceptionally crisp and the colors vibrant, completely avoiding a blurry look even at lower resolutions. All of this was achieved despite a small VRAM pool and limited raw compute power, proving it was a remarkably clever GPU rather than a brute force one. So why did it fail? Aside from rampant piracy, its completely new internal architecture meant it had zero backward compatibility with older Sega games. But arguably, the biggest nail in the coffin was going head-to-head with the undisputed titan of that era, the mighty Sony PlayStation 2. With the transparent shell securely fastened, this Hello Kitty limited edition Sega Dreamcast is officially and fully restored. By the way, this was the very first console to feature out-of-the-box online connectivity just by plugging in its modular modem. The controller is equally innovative, featuring a slot for a mini memory device that actually doubles as a standalone portable game system. And if you're wondering why it includes a keyboard, it's because this console lets you actively browse the web, send emails, and chat online directly. With all the peripherals hooked up, it's time for the final boot test, which is a massive success. Now, let's take a look back at how this console originally looked. That wraps up today's restoration video, and thank you all so much for watching as these joyful moments always fly by. Once again, thank you for tuning into Max's Restoration Realm, and I will see you next time.